Okay, linear inequalities. We're going to draw a fairly lengthy chart to talk about all the different types of inequalities before we actually start solving inequalities. Okay, so let me kind of get it set up and you'll see how you need to set your paper up. Okay, so here's our table. We got 4 column headers, type of interval, set notation, interval notation, and graph. Okay, so the first 4 type of intervals that we're going to look at, they're all called open intervals. So I'm just going to write it in the middle of 4 lines, so I don't have to write it 4 times. Actually, could probably go ahead and draw this line all the way across. Okay, set notation for the first open interval that we're going to look at looks like this. You guys are going to get some practice drawing squiggly brackets today. Let me draw it a little bit better. I'll zoom in some. Squiggly bracket, X, and then we have a vertical line. X is greater than A, close the squiggly brackets. And we'll kind of talk about what those symbols mean in a second. Okay, so the way that you read this is the first squiggly bracket opens the set. So we say the set of X values. This vertical line means such that. So the set of all X values such that X is greater than A. How about we write that so we don't forget? Let's see. So leave enough space. We're going to do 4, actually we're going to do 5 more intervals after the 4 open ones. So just make sure you have enough space for that. And then we'll come down here. set of all x values such that x is greater than a. Okay, interval notation for this interval that we're looking at is a parenthesis, a to infinity, parentheses. So the parentheses mean that this, whatever number this a is not actually included in the interval. It's just our starting point. If it were included in the interval, we would use a square bracket instead of a parenthesis right there. With infinity symbols, you always use parentheses. You never use a square bracket. We'll look more at square brackets when we look at closed and half open intervals. Okay, so the graph of this interval is just a number line. And we're going to mark where A is with an open circle. So make sure it's clear that this is an open circle. Right. Yeah, because we will look at some where we actually fill in the circle, but this one has to be open since, yeah. So it's open because we're not including A in our interval, but we're including all the numbers that are greater than A. So we're going to shade the right side of this circle. We'll draw an arrow. So starting at A, we have all the numbers that are greater than A shaded. But we don't shade in A because we're not actually including that in our interval. It's numbers that are greater than A, not greater than or equal to. Let's look at the next open interval. Set notation. The set of all x values such that x is between A and B. So x is greater than A but less than B. We write that as a compound inequality, a three-part inequality, I guess. That interval notation would be from A to B, parentheses on both sides. And our graph will look like this. Open circle at A, open circle at B, because we're not actually including those numbers in our interval. We're only including the numbers between A and B. So shade the line in between those circles. So we want the set of all the values that are between A and B.
So is this what our answers will look like?
Mm-hmm. Yeah, technically all three of these are answers for when we solve an inequality.
Will we have to give all three?
No. Well, yeah. Just for practice. Most likely, if you see something like this on a test, I'll have you answer in a specific way. Set notation, interval notation, or with a graph. But for practice, we're going to do all three. Okay, next open interval, the set of all x values such that x is less than b. So this is almost the exact opposite of the first one that we did. So our interval is from negative infinity up to b, not including b. So we still using the parenthesis and not square brackets.
So you'll never put X right there?
Nope. Okay, our graph is going to be an open circle at b. And we want all the numbers that are less than b, so we're going to shade the line to the left of b. Last one, set of all x values such that, and we got some more symbols here to talk about. X is in the set of all real numbers. Let me zoom in. This symbol here, it's basically a lowercase c with a line through it is how I draw it. It kind of looks like an E almost. And then this capital R just has two lines. You just add an extra line in your capital R. So it's just shorthand to mean that X is in, so it's X is included in, that's what that symbol means, the set of all real numbers. That's what this R symbol means, the set of all real numbers.
Is that just like a L and R combined? Like a line behind the R that connects?
Yeah, I kind of connected it to my line here when it shouldn't be. It's just, I just draw, like you would normally draw this line, and to make your R, I just draw another one and then make my R. I made it look worse somehow. Whatever. Which ones? I'm making it worse with my eraser marks. I'll come up here. Yeah. Okay, so all this means is that our interval includes all real numbers, which is all the numbers from negative infinity to positive infinity. So that's what our interval notation looks like, negative infinity to positive infinity. So the graph on this one looks a little bit weird. We have our number line. We need to shade all of the numbers on the number line. So we shade the majority of the line, and we're going to draw arrows on either side to show that the shaded region should actually go all the way to negative infinity and all the way to positive infinity. Okay, the next four types of intervals that we're going to look at are half open. So we got four more intervals, and they're all half open intervals. Okay, the first one in set notation, the set of all x values such that x is greater than or equal to a. So the half open intervals use greater than or equal to symbols or less than or equal to symbols. So in the interval notations, that means we're going to be using some square brackets instead of parentheses. So the half open, we're including a in our interval. So we use a bracket to show that we're including a, and we're looking at all the numbers that are also greater than a up to infinity. We never use square brackets with infinity symbols. You always use a parenthesis, mainly because you can't ever reach infinity to actually include it in the interval. It goes on and on forever. So this graph is going to look very similar to the first graph we drew, except instead of an open circle at A, now we're drawing a closed circle because we're including A in our interval. And we're also including all the numbers greater than A as well. So we shade the right side of the line. Okay, the next one, we have the set of all x values such that we have a three-part inequality, x is greater than or equal to A and less than or equal to B. Okay, so we've got square brackets from A to B, using square brackets on both sides because we're including A and B in our intervals. So our graph is going to have closed circles at A and B, and we're going to shade in between. Okay, next one, in set notation, the set of all x values such that we have another three-part inequality. X is greater than A, not equal to. We're not using an or equals to symbol on that one. But X is less than or equal to B. Okay, so we're not including A in our interval, but we are including B. So our interval notation has a parenthesis on the A side and a square bracket on the B side. So that means our graph has an open circle at A, but a closed circle at B, and X is anything between those, so we are still shading between A and B.
Why did you put 52 on the A?
Because we just have a less than symbol, or a greater than, I guess
Okay.
X is greater than. There's not an or equals to on that one. So there's actually another interval that would be basically the exact opposite of this. We're just not going to do it, where we do have an or equals to symbol here, but not here. So it would just be the opposite. You would use a square bracket with A and a parenthesis with B, and then you would have a closed circle at A and an open circle at B. But we're not going to write that one. Just know that that is a possibility. The last half open interval we're going to write is the set of all x values such that x is less than or equal to b. So that is from negative infinity up to b, and we are including b this time because we have an or equals to. So we use a square bracket in our interval notation and a closed circle on our graph. So closed circle at b, x is less than or equal to b, so we shade the left side of the line. Draw an arrow to show that we're going all the way to negative infinity. So now we're going to look at how to actually solve an inequality. And we're just going to do a few examples. First example, x minus 7 is less than negative 12. The way that you solve an inequality is not much different than how you solve an equation. We're just going to solve by getting x by itself. So since x has 7 subtracted from it, to get x by itself, we add 7 to both sides. Negative 12 plus 7 is negative 5. Once you have x by itself, you have solved the inequality. Now we're going to write our solution in the 3 different ways that we just did in our table. Set notation, interval notation, and we're going to draw a graph. So the set notation is pretty easy. All we do is use this inequality that we've already solved. So the set notation is the set of all x values such that x is less than negative 5. Our interval notation, x is less than negative 5, so we're going from negative infinity up to negative 5, and we're not including negative 5 because this is just a less than symbol. It's not less than or equal to. So that means we use a parentheses on both sides. And then our graph, we're going to have an open circle at negative 5. And x is anything less than that, so we're going to shade the left side. Yeah. Okay, example 2. $14 plus 2m is less than or equal to 3m. So we want to solve for the variable. Right now we have 2 different terms that have m in them. So we want to get those terms on the same side. So since this is a positive 2m, I can move it to the other side by subtracting 2m from both sides. So we're left with 14 is less than or equal to 3m minus 2m is just 1m, which we can just write as m. We have the variable by itself, but in an inequality, you usually want the variable on the left side. So we're going to switch this around. When you do that, make sure that the symbol stays oriented the way it is. Right now, if you think about when you learned inequalities, you probably talked about an alligator's mouth. Right now, the alligator mouth is open towards the M. So when we rewrite this, it still has to be open towards the M. So I need to flip my sign. M is greater than or equal to 14. Now we can write our solutions. In set notation, the set of all M, careful here, we're using a different variable, set of all M values such that M is greater than or equal to 14. Okay, our interval notation, M is greater than or equal to 14. So we're using a square bracket on 14 up to positive infinity. And you never use a square bracket with an infinity symbol.
How do you know where to put it? Why do you put 14 first?
Since M is greater than or equal to 14, I know that 14 is my starting point, and then I'm looking at numbers bigger than that. Yeah. So my graph, we have a closed circle at 14, and M is greater than or equal to, so we're shading the right side. All right, we got a few more examples. Example 3, 5m is less than or equal to negative 30. I want to get the variable by itself. So since it's 5 times m, we can divide both sides by 5 to get m by itself. Negative 30 divided by 5 is negative 6. So we got the variable by itself. The inequality is written in the correct order, so we can write our solutions. Set notation, the set of all m values such that m is less than or equal to negative 6. And since m is less than or equal to negative 6, I know that negative 6 is kind of my stopping point, so it's going to be on the right side of my interval notation. We're going to start at negative infinity, go up to negative 6, and we are including negative 6 in our interval because we have this or equal to line on our inequality. So we use a square bracket. And our graph should have a closed circle at negative 6, and the left side should be shaded. Example 4. Negative 4k is less than or equal to 32. Okay, similar to number 3, to get k by itself, we need to divide both sides by negative 4. So we're left with k on the left side, but then we have to remember a rule about inequalities. When you're solving an inequality and you either multiply or divide by a negative number, that flips the sign. So since we're dividing by a negative 4 here, this sign that is a less than or equal to sign now becomes greater than or equal to. So, yes. So let's make a note here, that way we don't forget. When you multiply or divide by a negative, flip the sign. So if we look at example 3, even though we ended up with a negative number after we divided, we weren't dividing by a negative number. We divided by a positive 5. So the sign doesn't flip even if your answer becomes negative. It's only if you are multiplying or dividing by a negative.